Hello, we're going to be working on Chapter 1, Section 8, Exploring Transformations. This is the first section where we actually talk about transformations that are going to describe the graphs of functions. And we're going to tie all this together as we learn more about it. This is a year-long process. You're going to have lots of questions, and there's going to be some things that might make sense now, but it's going to get a little confusing later. It's okay. We'll all get through it. It'll be okay. Ask your questions in the discussion and believe in yourself. You can do this. It'll be all right. One of the major themes of the Algebra 2 class is we're going to talk about how we have groups of functions that have the same characteristics. That'll be later in these videos. And we call them families of functions. And within a certain family, like the quadratics or the absolute value families, within those families, there's always modifications you can make from one to make it look like another one. These are called transformations. Transformations fall under three different categories. There's going to be translations, which are slides. So we're going to slide things left or right or up or down. There's reflections, which sometimes we call flips, and then there's going to be stretches and compressions. Those two go together. It just depends on whether you're making it bigger or smaller. All right. If some of that sounds familiar, you may also remember rotations, but we do not do rotations, at least not now. That involves some trigonometry that comes up later, and you might actually get into it in pre-calc. But for our purpose, we only need to worry about translations, reflections, and stretches, compressions. All right. We introduced this idea first by talking about points and specific points that have an x-coordinate and a y-coordinate. Later, we'll kind of mention it a little bit in the 1-9 stuff that I'm including here, where there's just one part of Chapter 1, Section 9 that I'm going to include in this week's material. Normally we would do it separately. We're going to mention it there, but you're not going to, we're only going to know how to do it just by looking at the pictures of the graphs. But just remember that a function is just a set of points. So if I drew like a linear function, that would have an infinite number of x-coordinates paired with a y-coordinate. All right? So this interchangeability between a function and a set of points, that's something we'll be switching back and forth. All right? And again, I know that probably gets confusing. Heck, just me saying it probably makes it confusing. But it'll be okay. We'll figure it out. All right? So for our first example, all we're going to do is we're going to be talking about translating points. And I stole this from the book, and I'm going to explain what's going on. So for horizontal translations, which go left or right, so here's left and here's right, all you're going to do is you're going to take the horizontal part, which is the x, and you're just going to add h to it. And remember, h is just going to stand for any number, so it could be positive. So if h is positive, it's going to move to the right. Or if h is negative, you're still going to add a negative, but that looks like subtraction. If h is negative, it's going to go to the left. And that's all that you're going to do. You're going to slide it to the right or to the left. So for this example that we have here, you get the point 1, 2, and we're just going to slide it or shift it. Some teachers use the word shift. We're going to shift it to the right by 3 units. So I add 3 to the 1, and I end up with the point 4, 2. And if you're wondering, when does it get hard? Not right now. That's all there is to it. For vertical translations, the idea is exactly the same, except you're going to work with the y-coordinate. So I'm going to add a number to the y, and if that number that I add is positive, the whole thing goes up. And if that number that I add is negative, so it looks like subtraction, then the whole thing goes down. All right? And it will be the case that you're going to move diagonally. And if you move diagonally, that simply means that there is a vertical component and a horizontal component. You're going to do both. So you're going to go right or left, and you're also going to go up or down. All right? That idea of a vertical component and a horizontal component for a diagonal, there's a whole bunch of math there that actually applies to upper level math called a particular area called, when we talk about vectors, and then vectors are useful in a lot of places in physics. So you're going to be seeing that idea pop up in different places. All right, so just we're just planting some seeds now. Okay, so, and again, you don't have to copy this down. This page is in the book, and also I'm going to take a picture of it later, right? So I'm not going to write on this. I'm actually going to use this to do the next problem. All right? So the problems are going to look like this. It's going to say, perform the given translation of the point 2, -1. And then you're going to give the coordinates of what you have here, okay? So, first part, I'm going to go 4 units to the left. Left is horizontal. So I'm going to use this key, all right? So my x, y is going to become x plus h, y. Now the only thing is I just have to know what those numbers are. That comes from that right there, all right? Now, I'm going to the left 4 units. So that means that my h is going to be -4. Negative goes to the left, and 4 means 4 units. My point is 2, -1, so I'm going to start with 2, -1. And notice I'm using an arrow. The arrow means it's going to shift. They are not equal. Points cannot be equal to each other anyway, okay? So the idea, the concept of equal doesn't make sense when we say points. So I don't want to do that. I'm just saying that 2, -1 is going to move. That's a very important idea when we're talking about transformations. Transformation means change the shape. So it's actually going to move. And when you look at the stuff that I posted about Desmos, and we do the Desmos stuff, the cool thing about Desmos is that it actually animates it. So you can like grab the slider and move it, and you can see the graph moving. All right, so keep that in mind. All these transformations involve movement of some sort. So we're going to move this 4 units to the left. So I'm going to get 2 plus -4, which is 2 minus 4. Now, I didn't go up or down, so the y is going to stay the same. The only thing I have to do is I just have to simplify. 2 minus 4 is -2, and my new point is at -2, -1. For the second part of that, I'm going to go 2 units to the right and 3 units up. So I'm going to do, my original point is going to be xy. It's going to get shifted. I'm going to add h to the x, and I'm going to add k to the y. Now you're probably wondering, what does h and k mean? What do they stand for? That's a great question. Sometimes the letters that we're going to use do stand for things. They make things a little bit easier. But in this case, they really don't. The way we mathematicians use English letters for things, a lot of times, like the first part of the alphabet, and when I say first part, like it kind of goes as far as we want. We use those for certain situations. The middle part, we use those in different situations. Like we use M for slope, which means monte, although that may not necessarily be true. So, and the H and the K are in there. We're just using it as a placeholder. And and by the way, the end of the alphabet is where we kind of like find our variables, X, Y, and Z. Sometimes W and some other stuff. You're going to see English letters used in different ways. To be honest, we have more concepts in math than we have letters. We run out. So that's why sometimes we use Greek letters, like delta and epsilon and omega and the world famous pi. So don't worry about why it's H or why it's K. H and K just stand for, H is how far right or left you're going to move. K is just a placeholder for how far up or down you're going to move. My point, same point, is going to be 2, -1. I'm going to go 2 units to the right, so that tells me that my H is going to be +2. And I'm going to go 3 units up, so that tells me that my K is going to be +3. So I'm going to get 2 plus 2 and -1 plus 3. And all I got to do is simplify that, and I get 4, 2. So if I was to graph this, and I don't have room to draw a graph, I apologize, but plotting points is kind of a pre-algebra skill, so I think you'd be okay with that. So if and we'll do some graphing at the other examples. So if I was to graph it, the point 2, -1 goes to -2, -1. It's going to slide 4 units to the left. And this one, start at 2, -1, and ends up at 4, 2, is going to go to the right 2 and up 3, so kind of in a diagonal direction. Let's do a couple different examples with a different point. So I'm going to go 5 units to the right. That tells me that I'm going horizontal. And again, the rule for horizontal is x plus h. And since I'm not going up or down, I'm going to leave, I'm going to leave the y. I started to write a k. My mistake. That's a y. It's an ugly y, but it's a y. All right. So if I go 5 units to the right, that tells me that my change, my h, is going to be positive 5. So my new point is -1, 3. That's going to become -1 plus 5, and the y value is going to stay the same because it's not going up or down. That's going to give me 4, 3. Finally, for this one, we're going to go 1 unit to the left and 2 units down. So I'm going to do both x plus h for the horizontal component, and no, I don't know if h stands for horizontal, okay, because k certainly doesn't stand for vertical. Y plus k, and my point, -1, 3, becomes -1. Oh, I forgot to do this. 1 unit to the left means h equals -1. 2 units down tells me that k equals -2. Should have done that first. So I'm going to do -1 minus 1 and 3 minus 2. And this simple addition is going to be -2, 1. Now that's all that you have to do for that. I am going to give you a heads up. When we start talking about transformations of the function as written by an expression, something weird is going to happen. I joke with Corbett that for the horizontal stuff, you end up in the upside down. Something really weird happens with the horizontal stuff. But it's something that we spend a lot of time talking about. I just want to warn you ahead of time that something weird is going to happen, but not right now. If you're looking at these 4 problems going, that looks pretty easy, you're good. That's all there is to that. I'll see you in the next video.